So new year, old rules. Make sure when we're in class, we don't do headphones, but y'all are mostly doing all right. But make sure you only do that if and when we get to some independent practice. We should probably get to that today. So yeah, it is obviously the third beard month, which is awesome. Check it out. All right. So, and then we got Cowboys winning everything, just 3 more games until. So the beard months are every single year. So yeah, January. Like Manuhairy, yeah. Hey, I literally grew out this beard for 2 months plus just for that one laugh. That was good. All right, and let's talk about radicals. Okay, so I think this class that I'm in right now is going to start focusing. I think everyone passed, which is great. Some better than others. Let's just stay on that train, get all our credit. It's a new year. So, all right, let's talk about perfect squares. Y'all know what a square is? So I'm not talking about a shape, I'm talking about a number, okay? So squares can be numbers as well as shapes. Okay, so like it says at the top, when working with the simplification of radicals, you must remember some basic info about perfect square numbers. You need to remember, and then here we go. So 4 is the square of what 2 numbers? So 2 times 2, right? And then 9, 3 times 3, hopefully you know 16 off the top of your head, and probably 25 off the top of your head, right? And then 36 is 6 times 6. It's really useful, in my opinion, okay, to know your squares. Meaning, you could just look at 81 and you know that's 9 times 9. Yeah, 64, that's 8 times 8, right? 100 is 10 times 10. So, a lot of people forget 49, 7 times 7, okay? And these are kind of obvious. Okay, yeah, so 121 is 11 times 11. I'm not telling you you have to memorize those, but it's helpful to know those, okay? So, on the next section to the right, it's basically working backwards. So, I know we've done some square roots this year, but just to make sure you know what they are, first of all, that little symbol that looks like this is called a radical, which is taking the square root of a number. So you could call it a square root sign or a radical, right? So if you have a perfect square number underneath a radical, then you get a whole number, right? So square root of 4 is, it's answering the question, what times what is 4? So it's going to be 2. And then square root of 9, 3 times 3 is 9, so square root of 9 is 3. And you get the idea with the pattern here. But I do want you to be able to kind of just see them and know it, right? So if you see a perfect square under a square root, it's a whole number, okay? So, as you can see, there's only like 10 squares between 0 and 121, right? So there's a lot of other numbers that don't give you whole numbers. So typically, if you type it in the calculator, you'll get a decimal, but we don't want decimals, so that's why today we're going to start off this year by reducing or simplifying radicals, okay? So that's what it's called up here, and that's what we're going to do at the bottom. So I'm going to show you how to do that. So let's look at the bottom left-hand side. So simplifying a radical, there are your instructions. I will explain that as we go along here, right? So everyone look at example 1. We have square root of 50, okay? So here's what we're going to do every time. We're going to do a factor tree, okay? which is really branching downward, so maybe it's more like a root system, but whatever, okay? So we got a factor tree. We're going to ask ourselves, what times what is 50? But, so it can be organized for us, we're going to make sure we use the smallest prime number. Now let's take a step back. Do y'all know what a prime number is? Yes. Okay. So prime numbers are only divisible by 1 and the same exact number. They do not reduce. They're not factorable. Okay, things like that. So prime numbers start at 2, and then you have 3. 4 is not prime because that can be divided by 2, right? And then you got 5, 7, 11, 13, 17, 19, and so on. Okay, so those are prime numbers. So we want to start with the smallest prime, which is always going to be 2. Okay, so whenever you do a factor tree, start with 2. And if 2 doesn't work, then try 3. If 3 doesn't work, then try 5. Okay, so that's what it says right here on this second step. Okay, so let's start with 2. Does 2 go into 50? It does, so let's write 2 times what is 50? 25. Okay. Now what did I just do? I just broke down 50, and if you break something down, I want you to cross it out. So 50 is gone. Now 25, can 25 be divided by 2? And it will not give us a whole number, so it's not factorable in that way. So let's try 3. Does 3 go into 25? Not as a whole number. 4, we skip it, but 5 does, right? So 5 times what is 25? Okay. Hey, that's one of those squares we were talking about. So yeah, 25 is 5 times 5. Cross out the 25. Okay. Does 5 break down further? Nope, those are prime. So please resist the urge to make more factor trees of 1 times 2 and 1 times 5. You're never going to use 1. 1's not a prime number, okay? What? 1 is an identity, a unit. No, but it's just, take my word on this one. Define number 1. The Dallas Cowboys are number 1. Woo! That was good. All right. All right, here we go. So, we got 3 prime factors. 2 times 5 times 5 would get you the original 50, okay? So, now what we're going to do is we're going to do story time with Mr. G. Y'all like to hear a good story with some humor along the way? Here we go. So, these 3 numbers, they're like friends, and they went to a radical house party. Right? It was going to be super rad, right? So, here's the deal. Like sometimes happens at parties, 2 of these numbers realize that they're so alike, they're so the same, and they're so compatible because they're the exact same number. And they became a couple. Aww. So, what couples do you see here? Not 2 and 5, they were incompatible, but 5 and 5, they matched up just right. So, 5 and 5. Now, here's the deal. They started dating. Another way of saying dating is that they are going out. And literally, they are going to go out of the radical. Couples going out. Get it? Nope. So, and we cross out 1 of the 5. So here's the deal. Every time you have a couple, one of them, it's so sad. Like they trip, fall down, break the crown, or whatever. And then they cease to be a number anymore. So here's the deal. Every time you have a couple, I want you to cross 1 out. In the end, it will hopefully prevent some confusion. But whenever you have a couple, it's just 1 number. Okay, so this 5 is going to go out because couples go out. Here we go. You with me so far? Then, inside the radical house is the loner. All by himself. Crying, sad, weeping. All right, and so inside we're going to put 2. And that's the story of the Radical House Party. You have romance, tragedy, depression, and math. It's great. So, square root of 50 is 5 square root of 2. Okay? So, when you're doing these, I got to see your factor trees. No shortcuts, right? So, let's look at example 2. Now, typically, you're going to have more than one of something. You might have more than one pair. You might have more than one loner. So the question that is going to be, as we continue, what do you do if there's more than one? So I will answer that now before we get there. But the answer is always going to be to multiply. So if you have more than one thing, what are you going to do? Multiply. So you'll see when we get there, and I'm going to ask you, what do we do? And you're going to say, multiply. All right, example 2. What do I do first? Factor tree. So, start with 2. Does 2 go into 24? 2 times 12. Okay? And does anything go into 12? Sorry, before I move on, what do I need to do? Goodbye, 24. All right, 12. Does 2 go into 12? Yep. 2 times 6. 12 is gone. What about 6? Does 2 go into 6? 2 times 3 is... Does 3 break down? Okay, so 3 is prime. So we have 4 prime factors. 2, 2, 2, 3. All right, so what do we do next? Let's find our couples. Do I have any couples? Got one pair of 2. Okay. The 2 and the 3 didn't work out. They're not compatible. They don't like the same music. Whatever. All right. Now, again, tragedy strikes. You know. Whatever. So we got to draw our radical house for the party. And remember, the couples go out. So the 2 is going to go out here. But now I got 2 loners. So here's the question. If I have more than one loner, what do I do with those 2 numbers? Multiply. Not add. Nothing else. We are going to multiply. 2 times 3 is what? 6. So, square root of 24, no. It's really 2 square root of 6. Okay? Reducing or simplifying the radical. Example 3, I got 180. So what do I do first again? Factor tree. So we start with 2. Does 2 go into 180? Okay, 2 times what? 90. 180 is gone. Does 2 go into 90? 2 times what? 45. Does 2 go into 45? Okay. Do y'all know how to tell? By the way, just as a pause, the way you tell, if you did not know, okay, if you divide something and you don't get a whole number, it doesn't work. Okay. Let's try 3 though. 45 divided by 3. See, that works. So 3 and 15 would be the factors of 45. So let's do that. 3, 15, and then 15, can that be divided by 3? Okay, 3 and 5. Now, 5 does not break down, it's also prime, so I have 5 prime factors, 2, 2, 3, 3, 5. And what do I do now? Couples. Do I got a pair of 2? Yep. And then I got a pair of 3. They were going to go on a double date, but there was a double tragedy. So sad. All right, so we got the radical party. Now, circled are my pairs. Pair of 2, pair of 3. What do I do with those 2 numbers? The answer is always multiply. 2 times 3 is 6 on the outside, and then on the inside, The loner is 5. Nope. So instead of square root of 180, it's 6 square root of 5. Okay? So far, so all right. So you can flip that over. Now we got a big old number, 1260, but we can do it. Okay? Let's break it down. 1260, we always start with 2. Does 2 go into 1260? Okay, so yeah, 2 times 630. And then that's gone. 630 is even because it ends in a 0. 2 times what? 315. Is 315 divisible by 2? Nope. So let's try 3. Does 3 go into 315? Okay. And again, you could, if you're not sure, 105. So 3 times 105. Does 3 go into 105? Okay. It actually does. 3 times 35. Calculator can help you. Does 3 go into 35? What? 3 times 35, or 3 times what? Would be 35, or no? No? Okay, so let's try the next one. Skip over 4. 5, does 5 go into 35? Okay, 5 times 7. And does 7 break down? No, because it is prime. Okay? So we have all prime factors at the end of our factor tree. 2 times 2 times 3 times 3 times 5 times 7 is 1260. So let's make our... No. So you can prove it. You can multiply them. But let's circle our pairs. So what do I circle? Pair O2. Pair O3. But you know what? It's so sad. They're gone. So, square root sign. What goes out? The 2 and the 3. What do I do with the 2 and the 3? Multiply and it makes 6. All right, so. Now, 5 and 7, those are 2 loners. They don't match. So what do I do with 5 and 7? Multiply, right? Tired? So 5 times 7, 35. So square root of 1260 is equivalent to 6 square root of 35. Okay? All right, example 5, though. On example 5, it asks us to find the square root of 76, but there's what in front of it? 5. So that's called a coefficient. Does everyone see that that's different? Okay? So there's an extra little step there that we need to know. I'll be honest with you. This is the one most people get wrong, and I'm going to show you exactly where people get it wrong, so you can avoid that. Okay? But we're going to start it off the same way with the factor tree. So 76, does 2 go into 76? Yes, it does. 2 times what? 38. Okay? Cross out 76, but leave the 5. 38 breaks down into 2 times what? 19. Does 19 break down? So 2 does not go into it. 3 doesn't go into it. 5, 7, 11. 19 is actually a kind of a big but prime number. Okay, so 19 is actually its own thing. Okay, now next step, typically we would do what? Circle our couple or couples, but in this case it's just 1 with a 1 goes away. Now, think this through with me. If you're looking at the square root sign, where does the 2 go? Outside. At the beginning of the problem, where was the 5? Outside. So if the 5 is already out and the 2 comes out, what do we do with those two numbers? The answer is always multiply, right? So it might help you to do this. If you see a coefficient at the beginning of the problem, think of that as a circled couple. Okay? That way you always think, hey, I'm going to multiply the circled stuff. 5 times 2 goes out. Okay? Technically the 5 was already out. Okay? So 5 times 2 on the outside is 10. And what loner goes inside? 19. So instead of 5 square root of 76, it's 10 square root of 19. Okay? That's the simplified version. And we say simplified because you want the least amount of number, like you want the smallest number possible under the radical. That's how we simplify it. Okay, so I want you to try 1 through 6, practice on your own. It's just like what we just did. So go ahead and do that now.